So this is the problem about the car accident, and it says a 1,055 kilogram van stopped at traffic light is hit directly in the rear by a 715 kilogram car traveling with a velocity of plus 2.25 meters per second. Assume that the transmission of the van is in neutral, the brakes are not being applied, and the collision is elastic. What is the final velocity of the car, and what is the final velocity of the van? I'd forgotten the traffic light, so there it is. Okay, let's see what we got. We have given the mass of the two. We have given the initial velocity of the car. We also have the initial velocity of the van because it says it stopped, so this one is 0. And we're supposed to come up with the velocity for the car as well as for the van, and notice that I don't put an equal in between because it's elastic, so once they actually hit, they actually bounce off each other, so they both have different final velocities. Now, in reality, of course, it's more of an inelastic collision that produces damage, but here that's what they want to have. They want to have like bumper cars, I guess. Okay, but what that means then is that with these two unknown velocities, what they want to figure out, that also means that we need two equations. And here's one of them, the momentum. So before and after. Before, the momentum is m1 v01 of the car, and then I could write the other down plus m2 v02, but that's 0 to begin with because the van is stopped. Okay, then after the collision, it's m1 vf1 squared. Oops, I was already thinking too far ahead. So it's m1 vf1 and plus m2 vf2. And sorry about these smears here. There, that's a v. Okay, so here are the two unknowns, the two final velocities. But then they say it's an elastic collision, and since it's elastic, kinetic energy is conserved as well. So 1/2 m1 v01 squared. You know what, I'm gonna make this easy on myself. Maybe this becomes actually more complicated. And for the kinetic energy, I'm gonna write 1/2 squared 1/2 squared 1/2 squared. Okay, so here I have the two equations for the two variables. Now the algebra would be quite involved. I would have to solve one over here and then plug it into the other one. However, there is an example in the book where they have already done that. I think it's example 7, collision in one dimension, where it says that it is elastic, and here's what they come up with, that VF1 equals M1 minus M2 minus M2 divided by M1 plus M2 times V01. And as I said, you know, if we did all the algebra, we could come up with that. So notice, by the way, that the final velocity of the car here depends on its initial velocity, and then, well, this subtraction here and this addition. But what I want to point out is that the mass of the van is larger than the mass of the car, and therefore this will become a negative, and therefore actually the velocity will come out to be negative, and that means that the car bounces back. And that happens when the car that rear ends the other one has less mass. Okay, for the other one, VF2 for the van, that equals 2 times mass 1, and all I'm doing here is just use that example where they already did the algebra for us and just write this down again. V01. Notice it doesn't look, one equation doesn't look symmetric to the other one, but here the reason is that there's a 0 on the V02, and same thing over here. So when you do the algebra solving for one or the other variable, it will make a difference, and as I said, it's not going to come out symmetric as would have been expected. So and then you come up with a result here. It's just a matter of plugging in the numbers, and the results are going to come out in meters per second. I made an animation for that. There it is. I saved myself actually putting the vans in here, so we have a couple of balls that hit each other with the same speeds. So here, and I put these in quotes here, this is the van and this is in quotes the car, with a velocity of 2.250 meters per second, and then I run this and then I stop it, and notice that this one rebounded, and this one here should be a negative 0.432, and this is a positive 1.818 meters per second. And once you actually calculate it, then you will see that this animation is really close to what you will calculate.